Hello, students. Welcome to our session of chemistry. Let us begin with a very beautiful thought. It is the quote of Lao Tse, which is actually one of my favorite, which says that the nature does not hurry, yet everything is accomplished. So, coming to our new session, in this session, we are going to discuss about the inorganic part of the chemistry. You might be thinking, what is inorganic chemistry? Well, the chemistry have several branches, as you all know. Among these are general, organic, inorganic, and physical chemistry. Inorganic chemistry deals with the chemistry of physical and chemical properties of the elements in the periodic table. So here we are going to discuss about the p block elements, and you know that S and p block elements together are known as representative elements. Among this, the p block elements belong to the group 13 to group 18. In this session, we are going to discuss about the general physical properties of group 15 elements, which is also known as Pnicogens. Pnicogens means the substance which causes suffocation or choking sensation, because some of the elements and the compounds of these group produces a choking sensation. Okay, so let us begin. What are p block elements? Elements whose last electron enters p subshell is known as p block elements. In a periodic table, you can see from group 13 to group 18 are known as p block elements. Now first let us look into their general electronic configuration. Electronic configuration is Ns2 Np 1 to 6. In p block there are metals, non-metals, as well as metalloids. You can also see that the first member of these block differs from the rest of the group, which is basically due to small size, high electronegativity, and unavailability of D subshell. Now let us go to group 15. Group 13 and 14 we have discussed in class 11 standard. So now we'll concentrate our discussion into group 15 elements. They are nitrogen family. In this group there is nitrogen, phosphorus, arsenic, antimony, and bismuth. You can see that among this, nitrogen and phosphorus are non-metals. Arsenic and antimony is metalloid, and bismuth is a typical metal. So we can say that when you come down the group, the metallic character increases. Now first let us look into the occurrence what we can say about the occurrence in the earth. As far as nitrogen is concerned, 78% by volume of atmospheric air comprises of dinitrogen. 78% by volume of atmospheric air comprises of dinitrogen. In earth crust, it exists as sodium nitrate, which is also known as Chile saltpeter, or in the form of potassium nitrate, which is also known as Indian saltpeter. So, what is Chile saltpeter? It is sodium nitrate. And what is Indian saltpeter? It is potassium nitrate. Also, the nitrogen exists in plants and animals as proteins and in their genetic materials. Now, what about phosphorus? The phosphorus exists in phosphatic rocks as phosphatic rocks. Since phosphorus is extremely reactive, it exists in combined state. You can say that they belong to an apatite family. They are fluorapatite, chlorapatite, and hydroxyapatite. The formula of fluorapatite is C3Ca3PO4 twice calcium fluoride. Chlorapatite will be thrice Ca3PO4 twice calcium chloride, and hydroxyapatite will be thrice calcium phosphate calcium hydroxide. They also exist in animal and plants in their living cell as phosphoprotein, which is particularly abundant in egg and milk products. Now let us look into the variations, the general trend that is present in group 15. If you look into the atomic and ionic radii, you can see that they increase down the group. Atomic and ionic radii increases down the group. Similarly, atomic volume and density, all these things will increase down the group. What about ionization energy? How does ionization enthalpy vary down the group? We know that as we come down the group, the size increases. As the size increases, ionization enthalpy decreases. Now, if you look into the ionization enthalpy, you'll find that ionization enthalpy of group 15 element is much higher than that of group 14. Not only that, ionization enthalpy of group 15 element is greater than group 16 elements, corresponding group 16 elements. Usually when we go from left to right in the periodic table, the ionization energy increases. But this group shows an anomaly. Group 15 elements have higher the first ionization energy. First ionization energy of the group 15 element is greater than that of corresponding group 16 element. Why? It is because of their electronic configuration. You can see that group 15 elements have exactly half-filled electronic configuration. And we know that half-filled and fully filled electronic configuration have extra stability Hence, group 15 elements shows higher ionization energy when compared to that of group 14 and group 16. Well, now let us look into the variation of electronegativity down the group. You know what is electronegativity? Electronegativity is the tendency to attract bonded pair of electron towards itself. It is a relative value. You can look into the value of electronegativity that is given in this slide. If you look into the value, you can see that electronegativity decreases down the group. Therefore, among these elements, the nitrogen has the highest electronegativity. Also, the nitrogen has the smallest size. Due to this, the small size, it has a capability to forming multiple bonds. That is, it is capable of forming p-pi bonds, which other elements are not capable. Hence, the nitrogen can exist as a diatomic gas. Nitrogen can exist as diatomic gas, whereas all other elements are polyatomic, usually tetraatomic solid, except for bismuth, which is monoatomic. So the question could be asked, why nitrogen is a diatomic gas whereas phosphorus is a tetraatomic solid? The nitrogen is a diatomic gas because of its small size and its capacity to form p-pi bonding, which other members are not capable of. Okay, phosphorus, due to its larger size, it is not capable of forming pi bond. Therefore, it takes on the shape of a tetraatomic solid, which is highly unstable. Therefore, the phosphorus, tetraatomic phosphorus, become extremely reactive. We'll discuss about this in our next slide. Now we are going to consider the question why nitrogen is extremely stable, whereas the phosphorus, which is belonging to the same group, is highly reactive. From our previous discussion, we know that nitrogen, being the first member, the smallest in size, capable of forming multiple bond, forms a triple bonded diatomic gas. It is due to this triple bond, which has very high bond dissociation energy, around about 941.1 kilojoules per mole, that makes nitrogen extremely stable at lower temperature. Whereas phosphorus, due to slightly larger size, not able to form multiple bond, takes on a tetraatomic structure which has got a lot of angular strain. Again I repeat, phosphorus, not being capable of forming multiple bond, takes on a tetraatomic structure with a bond angle of 60 degree. This causes an extreme angular strain. Therefore, P4 is extremely reactive. As far as metallic character is concerned, that we have seen earlier, that it increases down the group. We have also seen that nitrogen and phosphorus are nonmetals. Arsenic and antimony is a metalloid, and bismuth is a typical metal. If you look into their ionization energy, you will see that ionization energy decreases down the group, and their electronegativity also decreases down the group. All these factors actually increases the metallic character. Now, another important aspect in which the nitrogen differs from others, it is the only element which does not show allotropy. What is allotropy? The property of an element to exist in different physical form having different physical properties known as allotropy. The most important example of this allotropy is phosphorus in this group, having the three different forms. One is white phosphorus, red phosphorus, and black phosphorus. Among this, white phosphorus is highly reactive, and the black phosphorus is the stablest form of phosphorus.